We're going to start chapter 4 now. It's on discrete random variables. We have looked at this word discrete, we've looked at this word variables, and we know what both of those mean, so we're adding in this idea that we're looking at random variables that are discrete. A random variable is a variable that assumes a numerical value that is associated with the outcomes of an experiment. And each outcome is assigned just one numerical value. We typically will use x to stand for the random variable, and the value that x equals obviously can change from one outcome to another. Let's look at an example. Count the number of customers waiting in line at the Bruin Den at 12 noon. So x equals the number of customers. So let's think about what x can equal. Well, there can be 0 customers, 1, 2, 3, 4, etc. All right, to some max number. Okay, so now we want to ask ourselves, is that discrete variable or a continuous variable? Well, x is taking on integer values and skipping over a lot of values in between, so that makes it discrete. All right, let's look at another one. Toss a coin 2 times. Here's the sample space. You can get 2 heads, a heads and a tails, or the other order, tails heads or tails tails. Those outcomes are not numeric. So to get a random variable, we have to somehow convert that non-numeric outcome to something that is numeric. So let's define the random variable x to count the number of tails in an outcome. That way it becomes numeric. So we'll have x equals, well, like in the very first outcome, 1 and 2. So if we assign those values to the outcomes, the first outcome we get x equals 0, the second and third outcome we get x equals 1, and that last outcome is where we get x equal to 2. All right, so also we want to ask the question, do we have a discrete or continuous random variable? We're looking at the values that the variable takes on, so that would be discrete. Okay, so takeaway from that one, if the outcomes of the experiment are not numeric, then a rule is required to assign a numeric value to create the random variable. All right, let's look at this next one. Our experiment is we measure the length of time in minutes a customer waits in line at the Bruin Den and let x equal the minutes or partial minutes waiting to be served. So we want to think about what values does x take on? Well, x can equal 0. We can have 0 minutes of wait time, or it can equal any value up to, I don't know, some maximum value until they close. So we'll just say the time until Bruin Den closes. Okay, and because the value of x can be any number in that range of values, this would be a continuous random variable. Okay, now we want to look at something called a probability distribution function, or PDF, for a discrete random variable. A probability distribution function takes the form of a graph, table, or formula. And what it does is it takes the values that the random variable takes on and it associates a probability that that value will occur. So a PDF basically is matching up values of a random variable with a probability. All right, so let's look at an example where our goal is to create a PDF table, and it's going to require 2 columns. So we need a column for values of x and a column for values of probability. And if we take the experiment to be we toss a coin 3 times, we first want to write down what the sample space is. What are the outcomes that we can get? Well, we can get all 3 heads. And then we can get 2 heads and 1 tail. And that can happen in 3 different ways. The tail can come last, second, or first. And then we can have 1 head and 2 tails. And that can happen 3 ways. The head can come first, it can come second, it can it can be last. And then finally we can get all three tails. Okay, so this experiment has outcomes that are non-numeric, so we have to define that random variable to be something that is a number. So let's define it to be the number that's going to count the number of tails in each outcome. So x takes on, like in the first outcome, x is 0, and then in the next 3, x is 1, and in the 3 after that, x is 2, and then the last one, x is equal to 3. So if we want to just kind of write down the random variable value for each of those outcomes that we got in the sample space, we have 0, 1, 1, 1, 2, 2, 2, 3. Okay, so we found the we found the values that x takes on. Let's get rid of that. So we can create that column. So it takes on 0, 1, 2, and 3. Then we want the column of the probability that we get that value for x. Okay, so x is 0. That only occurs one outcome out of the 8 possible outcomes. So what we're doing is we're basically creating a relative frequency here. So the probability is 1/8 that x is equal to 0. And for x equal to 1, that occurs 3 times. So using that relative frequency, we get 3/8 for the probability. And then 2 is also 3/8, and then 3 is 1/8. Okay, that is what a PDF is, a probability distribution function in the form of a table. So we just take the values that x can equal and in table form list those in a column and then a column next to it with the probabilities that are associated with each of those values. We can also create a graph for a PDF where we have values of x on the horizontal and the vertical is the probability. So we need probability of 3/8 and a probability of 1/8. All right, so we've got 0, 1, 2, and 3 for values along the horizontal, and we'll create rectangles above those values going up to the corresponding probability. Okay, so that's the graph form of a PDF.